Welcome. I want to talk about prefixes here. Let's look at some examples. 1 kilogram. If you think of 1 kilogram, we know that this actually means 1000 grams. Now if I say 1 centimeters, we know that this means 1 over 100 of a meter. So if you look at the G here, okay, really means the same as the G here. It means gram. That means a gram. Now, but if that's the case, what does the K mean? The K here stands for kilo, and it really means this 1000. So kilo is a prefix. It's a symbol that we add in front of a unit, and it means some factor, some number of times, some number of that units. In this case, kilo means 1000. So that's why if we say 1 kilogram, it really means 1000 grams. Now in a similar way, if I look at this cm, and if I take apart the c and the m means the same as the m here, and that really means meter. So that's what the m here means. That's a certain unit of length. And guess what? The c here, which stands for centi, that's why we call this centimeter. Centi means this. It means 1 over 100. And again, we call C a prefix. It's a symbol that we could add to this to a unit, usually a base unit, to make up a new unit, which we call cm or centimeter. But why go through this trouble? Well, if we have something that is, say, 1 kilogram, it's easier to just say 1 kilogram rather than to go around saying 1000 kilogram. Okay, and if you say 1000 kilogram, you need to write down more digits, a bigger number with 4 digits as well, and that's more troublesome. And it gets worse if the mass or if the amount gets a lot bigger. You can have either very big numbers, or you can have very small numbers with lots of decimal places, like 1 over 1000, and we can also write it as 0. 1 over 100, we can write it as 0.01 meter. And if it is a very small number, there can be many decimal places. So instead of writing out so many, like 0.01 with 3 digits down here and a decimal place, it's a lot easier to just write 1 cm. And that's the purpose of using prefix, to make it easier to write down the quantity. So we are now going to look at a number of units, a number of prefixes actually. So let me start. Right, I shall start with the smallest. So this, right, I'm going to make a table with some columns. So let me call this first column prefix. Now, right. So I'll start with this first prefix. Now nowadays, if you might have heard of this prefix called nano. Nano becomes a very popular word in technology, and maybe even in the news sometimes. So nano, what does nano really mean? What does it mean? So I shall make another column here for the meaning. Now nano means exactly this. It means 10 to the power of negative 9. 10 to the power of negative 9. Now that might be a very small number that we don't normally use. We are not normally familiar with such a small number. So I'm just going to write this out just so you know exactly what it means in maybe a more familiar notation like a fraction. So it means 1 over 1 followed by 9 zeros. The minus just means 1 over. So it goes 1 and then 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. That's the meaning of nano. That's the meaning of nano. And if like for centi and kilo, all right, we need a symbol. We need a short form for us to write down units using this prefix. We don't want to carry around the 4-letter nano all the time when we talk about the units. So we need a symbol. We need a symbol S-M-B-O-L. That's symbol. And the symbol for nano, you might guess it, it's just the first letter, and that's N. That's N. Now how might I use this prefix nano? For example, if I say 1 nanometer, that means to see what this means, we analyze this like I did for cm or kg. Okay, the m here, I see that 2 letters. The second letter here always means the unit, just like the m here and the g here, which is gram. The first unit, the n, would be the prefix, and we have just learned that n means 10 to the power of minus 9. So all you need to understand what this means is to replace the n by 10 to the power of minus 9. Now what if it is 2 nanometer? What does that mean? Well, that just means 2 times of this. 2 times of this. So I can just write 2 times of 10 to the power of minus 9 meter. So that's how we can use this prefix nano. So let me continue with the next prefix. The next one is micro. And micro means 10 to the power of minus 6. So that would be 1 over 1 million. So 1 over 1 followed by 6 zeros. 1, 2, 3, 4, 5, 6. Now what do you think is the unit, the symbol for micro? First guess, it should be M. Now but unfortunately M is taken. Now just to remind you why that M is actually taken, recall this unit, mm. Right, you are probably familiar with mm. We use it now and then, even in everyday life. Mm stands for millimeter, and that really means 1 over 1000 of a meter. So that the milli here is a prefix as well, milli, which I shall come on to. Actually, is maybe the next one down. So for now, this means that since the letter M is taken, we need a different symbol, and the symbol that has been chosen for micro is this funny looking symbol. It doesn't look like any alphabet in English that you know, and that's because it is not an English alphabet. It is really a Greek letter. Greek as in the country Greece in Europe. So this Greek letter is pronounced as mu. Mu. In English, it's a Greek letter. So right, so we use this symbol and we call it mu, or you can just call it micro when you say it. Okay, now let's move on to the next prefix, and as I've already said, that's the milli. That's M-I-L-L-I, milli, and the first letter here would be the symbol M. And that would be 10 to the power of minus 3, which is 1 over 1000. Let's press on, and the next unit, right? The next prefix is the centi, which is that one that we have just seen. Centi, and the symbol would be the first letter C, and the meaning of that is 10 to the power of minus 2, which is 1 over 100. Let's press on. The next one. Now the next letter is a slightly less familiar prefix. It's called deci. Deci. Now the symbol for deci is D, and the meaning is 10 to the power of minus 1. So this letter is less commonly used, and it means 1 over 10. Okay, let's look at the next one. The next letter is kilo. That's right, we are on kilo now. We have already seen what kilo means, as in a kilogram, and it means 1000. Right, so the prefix is kilo, K-I-L-O, and the symbol is K, and the meaning is 10 to the power of 3, 1000. This is followed by the next one. The next one is mega. Mega. Now mega, once again, we can't use the first letter M, but we have already had a mu in place of M in micro. So this time, for mega, we use capital M for the symbol. Capital M, so be careful. Capital M and little m means different things. Capital M and little m mean different things in the prefix. The meaning of this is 10 to the power of 6. So that's 1 million. That's 1 million. 1 followed by 1, 2, 3, 4, 5, 6, 0. And the last one that we are going to learn here is giga. Now you're probably familiar with giga these days because we talk about gigabytes in computer file memories. So giga, you might even have seen this big letter G for gigabytes. Okay, and that's the symbol, the big letter G, and that means 10 to the power of 9. That's 1 billion. So 1 followed by 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 billion. So that's a giga. Now that's essentially a bunch of definitions that I have described. Those just symbols and the meanings. Now, but how do we actually use this? We've already seen an example of how this is used from here. Okay, you just put it in front of an SI unit or base unit, and then you can work out what it means just by putting in the meaning, which is a number in front of the SI units. Now, but the important thing about using prefixes is to know how to convert between different units or units of different prefixes. So I'm going to look at one example. We have already seen a few examples here. Like if you want to convert from 2 nanometer to meters, all you need is to replace the n by 10 to the power minus 9. But what if I want to do something slightly more complicated? What if I want to convert a unit that contains more than one base unit, so like velocity? So let me take a look at that example now. Okay, velocity. So what's the unit for velocity? That's meters per second. That's the unit for velocity. Let me think of an example. Suppose I have something like no, okay, actually I won't do velocity. I'm going to do something slightly more difficult. I'm going to do density. So let's say I want to look at the density of oil. And let's say that's equal to 0.8 grams per centimeter cubed. Now that's a complicated looking unit. So gram being the mass and cm cubed the volume. Now suppose that I want to convert this to the SI units, meaning I want to write this using the unit kilogram per meter cubed. Now this particular conversion causes a lot of difficulty for students because it's actually rather tricky to do this conversion. So let me run through this example now, and hopefully you'll get it right next time you do this. Now in order to do the conversion, we need to look at the units one by one. We need to think about how to convert grams to kilogram. Now as we've already seen, 1 kilogram means 1000 grams. That's because kilo means 1000 as we've seen here. But what about 1 gram? What is 1 gram in terms of kilogram? How many kilograms are there in 1 gram? If you just look at this previous relation, you see that 1 gram is really 1 over 1000 kilogram. You can get that by dividing both sides of this first equation by 1000. So that's that. If I then think about the cm, okay, we know what cm is. We've already seen that. It is 1 over 100 meters. Now from now on, I'm going to write this as a power of 10. It's a bit troublesome to carry fractions around all the time. So so 1 over 1000 would be 10 to the minus 3 10 to the minus 3 grams. Oh no, okay. Perhaps I'll just leave it as it is for now to make it look a bit more familiar. So having seen this, how am I going to convert this to this? Right, that's what I need to do next. So the next thing that I'm going to do, okay, I guess I don't need that now. Just going to clear that off. Okay. So let me now think about the gram per cm cubed. Instead of doing 0.8 grams, I'm going to just make things a little simpler. I'm just going to use 1 gram per cm cubed and find out what it looks like in the units of kg per meter cubed. So 1 gram per cm cubed, how are we going to do this? Right, the way to do this is to treat the units as if they are variables in an algebra equation. Okay, right, never mind. In case you haven't learned this in algebra yet, let me just write it this way. I'm going to write it as 1, and I'm going to take the stroke here to mean g over cm cubed. So I'm going to take the stroke here to mean a fraction. So we actually have a fraction here, and what this means is just that so the one of this is what we're looking at. Now the g, what I'm going to do now is I'm going to look at what g is in terms of kg, and I'm going to think of the g here as exactly this. Okay, I'm going to think of the g here as just this. So I'm going to replace the g here by this. I'm going to substitute this into the g there. So that's going to look like 1 over 1000 kg. Okay, just going to use another color. And the cm cubed here, the cm is this. Cm is 1 over 100 meter. Now the cube here means that I have to take the cube of the whole thing, of the whole of this. So I should put a bracket around it just to make sure that I get it right. And I'll take the cube of this. Now I still have the 1 hanging around here. Since the 1 here just means 1 of this, it's the same as saying that it is 1 times this, right? So that's just what it means. And then if I press on, I can now simplify this. So I'm going to I'm going to do this 1 times. So the 1 over 1000, I'm just going to write it out here. I'm just doing my my multiplication and division here, and over 1 over 100 means times, right? We have to flip it, so that's we have to invert this, so it becomes 100 over 1. That's what you do when you divide by a fraction, and we need to cube that, so that's cubed. So notice that I have left out the units for now, and I'm going to write them right into here on the side. So kg is just going to be kg. Now over meter cube. So I've just said that the stroke here means the same as a divide. So I'm going to put back in the stroke in place of this divide, and I'm going to put in the meter cubed down here. So we're almost there, and now all that remains is to simplify this. So with some careful multiplications or cancelling, you'll find that you get 1000 for your answer, and the units is now kg per meter cubed, right? So let me copy that out below here. So 1 gram per cm cubed is equal to 1000 kg per meter cubed. Now going back to my original problem, I need to know what is 0.8 grams per meter cube. So if I know 1 gram per meter cube is 1000 kg, 1 gram per cm cube is 1000 kg per meter cubed, then 0.8 just means that it's like if I multiply both sides of this by 0.8 gram per cm cubed, right? If I multiply this by 0.8, I need to multiply this by 0.8 as well. 0.8 times 1000 is equal to 800. So therefore the answer is 800 kilogram per meter cubed. So that's how we arrive at this. So for future work, for later things that we're going to learn about physics, it is going to be very, very useful to remember this conversion for density, that 1 gram per cm cubed is equal to 1000 kilogram per meter cubed. And this is particularly important because it just so happens that this is also the density of water.